Hey, good morning, everybody. So this is our lesson for Monday. Happy Happy Monday. Um, what we're gonna do is I've kind of taken sections 2.2 and 2.3, smushed them together, but broken them over 2 days. So we're not covering two sections in one day, but I've reorganized it so that it fits more of what I think would flow better. Okay. Now these two sections are all on the same topic. They're all actually on problem solving, which is fun stuff. That means we're going into word problems, but that's no big scary thing. We're going to build slowly. Okay, so the first day we're going to just look at three different things. Okay, three different varieties. We're going to look at percentages and pie charts. Then we're going to look at when we give you formulas, how you plug into them and find solutions. And then finally, we're going to look at when you have equations, how do you solve things to find your answers. Okay. So let's jump into examples and we'll learn through our examples, okay? So my pie chart's kind of hurting, but don't hate on it. So let's just say this pie chart, let me make it so there's less things in our way. So this pie chart below shows you what 200 surveyed college students spend most of their time on. So what's their most time-consuming thing? Okay, some of them answered social media, some homework, some texting, some hanging out, and some sleeping. Okay, notice I have the percentage covered on sleeping. So this is a pie chart if you did not know that. I think everybody knows that, but just in case, that is a pie chart. Now the first question we'll ask you is what percentage of students spent the most time sleeping? And I do want to point out something. A pie chart, we have to remember the total. Whoops, I gotta get a pen actually. The total should equal 100%. So it would be probably good to add up what we have and see what is missing to get to 100. So let's think about that. 30 plus 25 plus 15 plus 12. Okay, and let's see what that is. Let's see, 30 plus 25, that is 55, 65, 70, 82. That's 82. So what is left out of 100? We could just subtract to see what's left, right? 100 minus 82, that's going to give us 18. So what percentage is missing? I bet this one is 18%. And I typed it in there so I could click and show you that it is 18%. Alright, awesome. That's fine and dandy. That didn't really take too much special thinking. But the next thing we want to talk about is, okay, well, how many students is that out of the 200? Because we know the percentage, but how many of them said out of the 200 that's their most time-consuming activity? Okay, so here's how we're going to do this. Let me scroll down a little bit, have some more space. So I just want to talk to you for a second about percentages. Okay, so a little bit of the lesson tucked in right here while doing this problem. To find a percentage out of something, all we have to do is multiply by the percent. But there's a catch. I just can't multiply by the percent as I see it. I just can't multiply 200 by 18. I have to make it the percent as a decimal. So if I ever ask you to find a percentage of something, all you have to do is convert it to a decimal and then multiply it by the total. Okay, so our total here is 200 and our percentage is 18%. So let's see, how do I convert a percentage to a decimal? Well, that's easy. You just take the decimal and move it twice. That would be 0.18. We move it twice because a percentage means it's broken up into 100 pieces, each percent is. So basically, or not basically, it is just dividing by 100. 18 divided by 100 is 0.18. So let's see here. So I can find how many students by just saying, let's take this 200 and let's multiply by 0.18. Okay, now let me grab a calculator to do this. And hopefully my calculator will not, move calculator, take up the whole screen. Let's see, 200 times 0.18. I get 36. So 36. Now what are we talking about? We're talking about students. So let's put units on these. 36 students. Awesome. That's how many said that sleeping was what takes most of their time. Now, if this were to have been a decimal, because we can't have a piece of a person, we would have rounded. This one didn't require any rounded, but we would have needed to round. Okay? Let's practice one more percentage problem. Not with a pie chart, though. Pie charts are so overdone. Something like this. So if COVID-19 has a death percentage of about 2.3% in South Carolina, and there are 124,000 cases in South Carolina, how many can we expect to die? Sorry, it is a morbid question. I just randomly Googled some of these numbers. I'm not sure if they're right or not, so don't quote me on any of these numbers. I just grabbed them off the internet, and we all know the internet's not always right. So, but anyways, just for current times, I thought I'd throw it in there, but now that I read it, it's kind of depressing. We'll do the problem anyways. So remember, we're trying to find the total, or how many, a percentage of something. I know the percentage that die is 2.3, and I know the total number that have it, so I can find that 2.3% of 124,000. So all I have to do then is multiply. Now let's see, how can I turn this into a decimal? I gotta move it twice. 1, 2. So I moved it an extra spot. I'm gonna need to put a 0 there. So 0.023. So all I have to do is multiply. Once again, I can't do that in my head, so let's grab a calculator, and I will have the total number. So let's see, let's clear things out, go away. 124,000 times 0.023 equals 2,852. 2,852. Once again, I do not know if these are anywhere near the right numbers. Don't quote me on these. Don't get upset either way, because these could be completely false. I just grabbed them really quickly to make this example. So this is deaths. Okay. Once again, because we're talking people, we would have rounded this just to make sure, but I made it so it came out to perfect. Sorry, I didn't mean to make everything perfect, but all right. So that's the percentage problems. We can ask you some of these on the test. As a matter of fact, you're going to get some on the MyMathLab portion of the test. I'm not sure if any's on the Blackboard portion, but I know there will be some in the MyMathLab, so you'll have these coming up, okay? You'll have some pie chart questions like this, and you'll also have some like this, okay? Now moving on. Now we're going to work on the type where you just kind of get a formula and all you have to do is plug in. These are called plug and chug type. That's what I call them. That's technically not what they're called, but so it says, look, here's the formula for interest. Okay? Now we do need to talk about what these things are. Let's see. Let's grab a different color. A is your amount that you have after the interest. Okay? P stands for the principal. I don't know what the spelling of this one is. It might be like that. It may be spelled the other way. R stands for your rate. N, notice N is in there twice, stands for number of times compounded. And T stands for time. This is going to be, we're going to do everything in this class in years. Okay. All right. So those are what those things mean. I actually think there's a simple question on the MyMathLab that just asks you that. But anyways, we're going to use this formula. So let's see. So reading the problem, it says your wealthy uncle finally passed away. Might have been COVID, but it could have been one of his ex-wives. They were all out to get him for the inheritance. And you get $10,000 in inheritance. Yay. I wish I had a rich uncle. All my uncles are poor. That's okay. I mean, not that I want to kill any of them off. Just, So you choose to place this money in a savings account that earns 4% interest and is compounded quarterly. How much money will be in the account in 5 years? See are these? Yeah, those are linked together. So to answer the one in red, all I have to do is think about the numbers I have. So the principal, maybe we'll highlight. The principal that's our P right here, is how much you're starting with. Okay? So that's the P. It says you choose to place this money in the savings account and it earns 4% interest. This is almost the R, but it's not quite. This is going to be exactly like the last percentage problems we did. Anytime I want to use percentage, I got to make it a decimal. So that will be our R, 0.04. I'll move the decimal place back twice. And it will be compounded quarterly. So this is where our N is come from, number of times compounded. How many times does quarterly mean? That means 4 times a year. Okay, so let's see. We almost have all the pieces of information besides the time, but the time is right here in the question, 5 years. I don't really have space, so let's see. How much money will be in your account? So the principal is 10,000. Okay, 1 plus rate, 0.04 over N, 4. Come on, thing 4. Raised to the 4 times 5, N times T. Alright, and because this is going to be kind of difficult to do, we're going to do this in a calculator. I would suggest you take it slow. I would do this chunk first in the parentheses. So we could do that in a calculator. Let me move this out of the way so you could see. So I might do the part in the calculator that is just, let's clear everything out. 1 plus, I'll use parentheses around the fraction, 0.04 divided by 4. And this might be a big, oh, it's just 1.01. That's not too nasty. So 1.01. Alright, and then I would do 4 times 5. We should know that that's 20. And then I could type all of that in the calculator to get the final answer. Okay, so 10,000, let's clear things out here. 10,000, 1, 2, 3, times, let's put it in parentheses like it's shown, 1.01, and then let's raise it to the 20th power. It's just the parenthesis raised to the 20th power, so I actually stick it back inside the parentheses once I figure out that number. It doesn't really matter. Alright, let's see how much you have. You'll have $12,201.90. $12,201.90. Stop that. $12,201.90. Because it's money, we can round to 2 decimal places to the cents. Be sure you do that in your problem, okay? Awesome. Now the next question is, how much interest did you earn? Interest is the amount of money that's being added to that $10,000, sorry. So if I wanted to find how much interest I earned, I could just subtract 10,000. I could subtract my starting amount from there. On my math lab, they will ask you both of these questions. So please pay attention to which one they're asking you. If they ask you how much interest you earned, that's not the total amount in your account. That's how much it changed by. And this is an easy subtraction. If I were to subtract those off, it changed by what? $2,201.90. That's how much I gained. Okay, so not too hard of a problem. Just subtract the 10,000 from it. Okay, so we could ask you both of those on the test. Okay, another one with a formula, but this one actually is going to be our first one where we actually get to solve something. But that's okay. We already know how to solve. Talks about food, my favorite subject. So, all the calories in a source of food comes from 3 things: carbs, fats, and proteins. And the formula actually for that is it's rounded a little bit, but it looks like this. The calories equals 4 times the carbs. Can't use C again, so I'm going to use an H. Plus 9 times the fats. Plus 4 times the proteins. Okay. So let's just say a serving of gummy bears, the frat feed snack, and has 200 calories in it. So we know information. Let's start sticking information in. We know the calories is 200, right? Because I have a feeling they're going to ask us for one of these things we don't know. I know it has, it's fat-free. So that means how many grams of fat? That means 0. So 9 times 0, I could do that one in my head. And it has 42 grams of carbs. So let's see. The carbs is 42. how much protein is in it. So I don't know the P. So I wrote down everything that I knew. I knew the C, I knew the carbs, I knew the fat. I don't know the protein. I can simplify. This is just turns into a solving problem. So remember our last lesson we talked about solving. Are there any fractions to kill off? No. Next, is there any simplifying I could do? And I could say, yeah, I can simplify here because I can combine these like terms and I can distribute 4 times 42. Oh, 4 times 40 is 160. So is that 168, I believe? Someone may want to double check me. Plus, oh, this is easy, that's 0. And I could add those together, 168 plus 0. Plus 4p. Now, do I have to get the p on the same side? It already is. I could just solve for p now. So, subtract 168 from both sides. Get a new color here. It's going to equal 4p. And let's see, what are we going to get? We're going to get 32. So now all I have to do is divide by 4. And that is 8. So the grams of protein are 8 grams of protein in this serving. Okay, so we just used our solving. They gave us the formula though, so that wasn't too hard actually. I call these fake word problems. Because a real word problem, you're not going to be given the formula. You're going to have to work hard to find it. But this is a test question, so just know it's coming, probably in the math lab portion. Okay. So let's look at the last type now, I believe. Yeah, the last type of day 1 is a revenue cost type problem. So let's read the question and then we'll talk about this. So you bake cakes as a business. Yay, I love cakes. The cost of making your cakes is given by the function in red there. Cost is equal to 12x plus 45, where x is the number of cakes that you've made. You sell your cakes for $15 each, giving you a revenue function of 15 times x. That's the blue. How many cakes will you need to sell to break even? So first, does anybody know what cost is and revenue is? Cost is how much money you're spending to do things, and revenue is how much money you're bringing in. So what we would like to do is asking when you break even. So for instance, if you start a business, it usually costs money. Like you have to buy the ingredients for the cakes, or you have to buy an oven, or you have to buy electricity, or you have to buy I don't know, a chicken to lay eggs. You have to buy something, you know. So that's where the cost is, and then your revenue is how much is coming in. Breaking even is when you no longer are negative. So basically, that's when the cost equals the revenue. So that's when the next cake you sell will be a profit. Okay, so it looks like you probably started out spending $45 on something, and the cost for materials of each cake, say you bought some fancy pans to bake in, and you can use those over and over and over again. You just paid $45. The ingredients for each cake is $12. You sell them for $15. So how many cakes can you sell to cover this $45 cost is what we're asking. So all you do on these break-even questions is take the cost function and set it equal to the revenue function, and then let's write down the actual function. So this side is 12x plus 45 equals 15x. Then just solve for x. And so we'll do the same solving steps that we always do. Any fractions to kill off? No. Anything to simplify, distribute, or combine? No. Do I have my x's on the same side? No, I gotta fix that. So let's subtract 12x from both sides. So 45 equals 3x. Now I can solve. All I need to do is divide both sides by 3. So how many cakes will I need to sell to break even? So x equals, let's see, 45 divided by 3 is 15. You'll need to sell 15 cakes before you start making a profit. Okay? Awesome. Now we'll talk a little bit about this one. If it was a decimal, we would need to be careful with rounding it. Okay? Just be cognizant of that. Think of that. All right? Awesome. So that's all I have for you today. On Wednesday, we will do the second half of this lesson. Okay? And on Wednesday, we'll build upon having to write our own equations. Alright? That's more so where we're going. And I'll hit a few varieties with you on Wednesday. Alright? I hope you have an awesome day. I will see you Wednesday.